Hello everyone, welcome to this video series on database management system. So in this video, we are going to discuss about lossless join decomposition. So in the previous video, I told you that whenever we are decomposing tables, we need to we need to see that the decomposition is satisfying two properties. One is whether it is lossless, and second one is whether it is dependency preserving. So in this, we are going to see the first one, lossless join decomposition. Okay, so let's see. So let's take a table R, or you can also say it is a relation. Okay, and it is having a set of FDs F. Okay, then whenever you are dividing that R into two tables, let's say R1 and R2. So this is R1 and this is R2. Okay, so R1 will have some attributes and R2 will have other attributes. Okay, fine. Now whenever you divided this one table into two tables, when you join them back, okay, this is actually join operator, so join will be looking like this. Okay, when you join the two tables, that is small tables together into a large table, again you should get the original table. Okay, whatever table you divided into two tables, whenever you join them, you should get the same original table. So if you are getting the same original table, that is called as lossless join. Lossless join decomposition. Okay, now let's see what is this with an example. So this is R. Okay, also consider this as small r, no problem. Now we are dividing this big table into two tables like this. In one table we are taking the first two attributes, in second table we are taking the second and third attributes. Okay, so if you see the previous slide, this x and y are subsets of attributes in original relation, right? So here x is this SP and this y is this PD. Okay, so this is x and this is y. Okay, now what are they saying? When you combine these two again, okay, when you combine these two again, you should get the same original table. So is it happening? So we are combining these two here. See, we are joining them. So this is join symbol. Okay, now how is join performed? First let's see how are we getting this table. So take the first row in the left hand side and do a cross product with all the rows in second table. Now only take the rows which are having same value under the common attribute. So common attribute here is P. So P1, P1. Okay, you can take this row. Okay, now this is P1, this is P2. You should not take this row. Okay, again P1, P1. Right? You got the row here. Fine. Now similarly take the second row and do the cross product. Now again check for same values, P2, P1, so ignore this, P2, P2, yes, so S2, P2, D2 will be there. Now P2, P1, so this is ignored. Okay, now take the third row and again cross product. So P1, P1, yes, here is the row. P1, P2, no, you should ignore this, P1, P1, yes. Okay, so this is how we got this table. So when we join these two tables, we are getting this table. So is this same as this? No. Okay, this row is here, this row is here, and this row is here. Now what are these two rows? So this is called as lossy decomposition. Okay, so whenever we are decomposing a large table into multiple tables, and again when you join them into a large table, if you get some additional tuples or rows in the table, that is called as lossy decomposition, but we discussed that it should be lossless. Okay, so this we don't want. First of all, why it is called lossy, right? Since we are getting here additional rows than the original table, right? Then why they are saying it is loss? So loss in the sense the consistency of the data is lost. Okay, this is not correct data, right? This is wrong data. This is correct data. Okay, since the consistency of the data in the table is lost, that is why it is called lossy decomposition. Okay, then how to make it lossless? Let's see. So to make the decomposition as lossless, so the attributes common to both the relations must be a key in either of the relations. Okay, the only simple point is whatever common attribute is there between the two tables, it should be a key in either one of the tables. Okay, it should not be in both tables, either one or the second table. Okay, so if you go back to the previous example, here what is the problem, why we are getting these extra tuples or extra rows is because P is not a key here, right? P is not a key. How I am able to say P is not a key? Because we have duplicate values. So we already know that key does not have duplicate values, right? So P is not a key here. What about here? Here also P is not a key. So that's why, since the common attribute P is not a key in either this left hand side table or right hand side table, when you join them, you will get these extra rows, and the decomposition will be lossy. Okay, right. Now here I am giving you three scenarios or three problems. So there is a table with attributes A, B, C, D, and it is decomposed into one table is having AB, another table is having CD. Here also it is ABC, CD, and here it is ABC, CD. So below I mentioned in each table what is the key. Okay, now my question to you is, which of these above decompositions is lossy and which of them is lossless? Can you tell me? So among these three, which of these three is lossy decomposition, and which of these three is lossless decomposition? So I already told you how to make the decomposition as lossless, right? Just now. So tell me the answer. You can comment your answer below the video. So let me know, right? Okay. Now let's see the previous example. So here in my instance, original instance, I have changed this P1 to P4. Previously it was P1 here, I changed it to P4. Now you can see P1, P2, P4, P1, P2, P4, right? So now I can make this common attribute P either as a key in this left hand side table, or I can make it as a key in the right hand side table, right? Now let's say it is key in this table. Okay, now when you join them, you will get the same original table which is same as this. So you can do the cross product and see yourself, you will get this same table, original table as this. Okay, so this is an example for lossless decomposition. So what is lossless decomposition? When you divide the large table into small tables and when you join them, you get the same original table, that is called as lossless decomposition. So how to make the decomposition as lossless? So whenever you decompose, take the common attribute and make it as a key in either one of the tables. Okay, it need not be key in all the tables. It should be a key in at least one table. Okay, right. So that's it about lossless decomposition in DBMS. So please like the video and also share it with your friends and subscribe to my channel. So if you have any doubts, you can comment below the video. Thank you.